All right, thanks. Let's see, there we go. So my name is Chris, and I have a lot to talk about, so I'm just going to jump right in. My agenda for this talk, I'll give you guys a little bit about myself. I'll talk about understanding how app complexity grows, managing app complexity through testing, and then at the end, I'll do a little bit of a wrap-up. So about me, I live in Nara, Japan, which is famous for having these deer that sort of roam free throughout the city. And it's also famous for having the largest indoor Buddha statue in all of Japan. Now, being a city in Japan, of course, we have our own city mascot character, Senta-kun. And Senta-kun is a Buddhist monk that they've put deer antlers on. So, yeah, totally not weird at all. Before living in Japan, I'm from Vermont in the United States, which is this kind of tiny little state in the northeast corner. And sadly, Vermont doesn't have a state mascot of our own. Man, but I wish we did. So we are famous for our senator and perennial presidential candidate, Bernie Sanders. So I don't know, maybe he could be our mascot, but something doesn't seem quite right. Ah, there we go, much better. Let's call him Bernie Coon. So, yeah, you're welcome, Vermont. Professionally, my background is actually, I started my career in security and distributed systems, mostly in C++. So I worked at BigFix, IBM, Subspace, and finally at Box. While I was at Box, I transitioned to more front-end and mobile and desktop client work. So I worked on our iOS team, our Mac, Windows, and web front-end teams. During the whole time, while I was working at all these different companies, I started developing an app on the side for myself for learning Japanese, which is called Nihongo. And I quit my full-time job, or I launched this on the App Store in 2014, worked it on the side, and then I quit my full-time job at Box in 2018, and I've been a full-time indie dev making a living off of this since then. So it's been about 5 years I've been a full-time indie dev. So just to give you a little sense of what Nihongo looks like, since I'll be using it as an example throughout the talk, it has some of the basic features you might expect of a Japanese dictionary app, a search screen where you can search for words to look them up, a word entry screen where you can see the definitions of Japanese words and their meaning and parts of speech and things like that, and a kanji entry screen. Kanji are the Chinese characters that are used in Japanese, and so in the writing system, so any decent Japanese dictionary will have entries for each of the characters as well, teaching you how to write them, how many strokes they have, things like that. But what makes Nihongo really special is its focus on helping you learn from the words that you're encountering in real life. So say, for example, you go and you're visiting Japan, and you are looking at a coffee beverage in a vending machine, and you want to know a little bit more about what you're actually picking out here. So Nihongo you can take a picture, it'll turn all of the words blue, so they kind of look like links that you can tap on. You can tap on one to look up a word. In this case, this says very low in sugar content. You can get to that same word entry screen where you can now attach that photo to the word so that the next time you encounter this word, you can remember, oh, I saw that when I was visiting Japan, and I looked at that vending machine, and I wanted a coffee. And so you're making those neural connections, with something you have actual context for. And last, it also automatically creates flashcards for you, so you can you can study these words with that extra context of where you encountered it. So that's Nihongo. Now let me jump into the main topic of my talk, which is called managing app complexity. And if I were to give this sort of a more detailed name, I might have called it having confidence that your app works as it's supposed to, even as it grows. So that's the kind of complexity I'm talking about here. So what do I mean by complexity? And there's lots of different ways we might think about measuring this. One way might be just lines of code. So these numbers are probably a little hard for you guys to see, but when I launched Nihongo 1.0, it was about 25,000 lines of code. Now I'm closing in on about 100,000 lines of code. So 4 times more code, does that mean that Nihongo is 4 times more complex than it was at launch? And I'd say no. I'd say Nihongo is far more than 4 times more complex than it was at launch. So let's look at this another way. It's a bit of an oversimplification, but let's pretend that Nihongo 1.0 just had these 3 features that I showed you earlier, the search screen, a word entry screen, and a kanji entry screen. So each of these boxes kind of represents a certain amount of complexity in the app, a group of functionality, and roughly correlating to a screen in the app. So we might call this a total complexity of 3. In Nihongo 1.1, let's say I added the photo lookup feature, and that adds 1 more complexity, so we're up to a total complexity of 4. In Nihongo 1.2, instead of adding a new screen, I'm actually adding iPad support. So I launched 1.0 with just iPhone support. And in a way now, each of these different features I've developed have 2 different ways that you interact with them, one on the iPhone and one on the iPad. And so I think of this as multiplying the complexity of the app. Now I've multiplied it by 2, and our total complexity is up to 8. In Nihongo 1.3, maybe I added that flashcard feature, which now that we have iPad and iPhone support, that adds 2 more complexity. And every time I add a feature onto the right, that's the kind of feature that just adds a new screen but doesn't really affect anything else earlier that you've developed, I think of those and I call them additive features. In Nihongo 1.4, I added multiple language support to the app. So forgive this. This is a terrible rendition of 3D perspective. This is kind of supposed to look like it's going into the screen there. So effectively, we've now got every screen we can view on an iPad or an iPhone in one of 3 different languages. And in a way, this says multiply the complexity by 3, so we now have a total complexity of 30, which is already far more than 4 times that initial complexity of Nihongo 1.0. So every time I add a new dimension to this structure, I call those multiplicative features. Now, just to sort of drive the point home, here's some more features and additive multiplicative features. Adding something like widgets to the app, that might be an additive feature. It doesn't really touch anything you've developed earlier. I recently added handwriting input to Nihongo. That's another additive feature. But something like dark mode, even though it only affects appearance, it might not be a massive change on each screen. It does affect every single screen in your app, so I think of that as a multiplicative feature. Dynamic type is another one. This affects the way that every single screen in your app is presented, so that's a multiplicative feature. I think of support for multiple iOS versions as a multiplicative feature, just because the way that each screen interacts with the system can be different on the different versions of iOS, and so they can cause different ways to interact. And lastly, voiceover support is another good example of a multiplicative feature. This is something that adds an entirely another way to interact with your app on every single screen. So the reason I call out additive versus multiplicative features differently is that I think about these features differently when I add them. And I definitely add multiplicative features, and these are all important things to support. But I'm much more wary about adding multiplicative features, and I think it's good to be cognizant of the impact that they're going to have, not only on your current development and how long they take to implement now, but they're going to add a cost to the implementation of everything that you develop in the future. They're going to make everything that you add, add a cost to that. So I showed you Nihongo 1.4, and my latest release is Nihongo 1.30. So I've had 26 more feature releases after this. So I want to give you a sense of what my mental model of Nihongo is in Nihongo 1.30. And unfortunately, I can't really represent like an n-dimensional structure in this 2-dimensional presentation, but I gave it my best shot. So here is what I think of as Nihongo 1.30. So each one of these squares represents one feature of my app, roughly one screen, but not necessarily, in one particular configuration. So for example, this square here might represent the search screen in German, on an iPad, in dark mode, on iOS 16, with extra large dynamic type. So back to sort of managing app complexity, this is what I'm talking about when I talk about complexity. This is what I have in my mind, is this sort of amorphous, blobby structure I've come up with here. And the point I want to make is that the difficulty of verifying correctness of an app scales with complexity. So I've kind of defined this idea of complexity, and this is what I mean by it. I don't think that the cost of actually implementing a feature necessarily scales exponentially in the way as you add these multiplicative features, but I think what does scale with it is how difficult it is to verify the correctness of your app. So when I said there was a cost in multiplicative features on all future development, this is the cost that I'm talking about. And so what I mean by that, if we look at Nihongo 1.0, this is super easy to verify. I can literally take out my iPhone, like make my final build I'm going to submit to the App Store, take out my phone, use the search screen, exercise all the functionality on it, go to the word entry screen, tap around, make sure I've used everything on there, go to the kanji entry screen, make sure I've sort of played around and used everything on there. And I can feel pretty confident when I hit that release button in App Store Connect that when users download my app, they're going to get pretty close to the same experience I just had. And so I should be able to cover everything, and they should. I can have confidence in my app release that way. But Nihongo 1.30, this is really hard to verify that it's working. It's not practical for me to install the app on every single device in every language and all these different configurations and iterate through every screen in my app and exercise every single piece of functionality. So this is how I think about my app and the challenge of verifying its correctness before each release. This object is constantly shifting and morphing and changing shape, and I kind of need to make sure I have eyes all over it, eyes that are kind of looking all over this structure on each of these squares so a bug doesn't sneak in. And that's hard to verify. Like, what if there's a bug that only occurs on iOS 16 in French with dark mode on an iPad? What if it's in some little crevice of this structure? And I tried to find an example of this in some of the recent work I've done to illustrate this, and this is kind of one thing I came up with. So this is, again, that photo lookup feature I showed you earlier. And I'm on an iPad, and what I'm going to show you is a layout issue that happens here. So when I slide from regular width to compact width, you can see it has this layout issue where the screen is not centered anymore. And if I do this again, now this time around, this is the iPad app, but I have the sidebar of my app actually pulled out and enabled. And now, when I resize it to compact, the bug isn't there. It sizes properly. It only happens if you watch. I toggle the sidebar to full screen, and then I go to compact width, and there's this layout issue. And this is the kind of thing. So we're talking about an iPad in multitasking, going from regular to compact with the sidebar toggled or not toggled. Even that level of just configuration is really hard to catch these kinds of bugs because you're not going to be testing every single screen of your app, moving from regular to compact width or compact width to regular width in every single screen with the sidebar toggled or not toggled. Like, even just this is already so many different pieces that this is an easy kind of bug to miss. So there's lots of ways we could approach this problem. And in my work, in the past at larger companies, I've seen a lot of different approaches. So one team I worked at just had a huge, absolutely massive QA team. Literally like 3 times the size of the development team was a QA team that every day their job was to come in and try to break the app and run through test plans and regression testing, and they just every day were there to try to break it. So if you have a massive team, maybe you can try all these different configurations and all these screens and work on it that way. I've been on apps that just have a big test flight beta, so 500, 1,000 users in their test flight beta, and you kind of can hope that, hey, that many users, maybe they'll use it in enough different configurations that you're going to catch all these different issues. Dog fooding, if you're not familiar with this term, this basically means having your own team use your app. So you have a build, you have your own team use it for a while before you actually launch it. The term comes from the idea that people that make dog food don't actually eat the own dog food that they make, so how do you know that it's good, is kind of the idea. And so dog fooding is this term that means, having your own, using it yourself, having your own team use it. But as an indie app developer, none of these really are practical for me. I don't have a test flight beta with thousands of users. I'm just me. I'm a solo indie developer. I can't have a big manual QA team. Dog fooding, I use my app every day, sure, but that's not going to cover nearly enough scenarios. So really the answer here is testing, unit tests and UI tests. And so for the rest of this talk, I'm going to just focus on testing and how we can use this to tackle that problem of verifying correctness as your app grows in complexity. So first, I'll just try to define a little bit what I mean by this in UI test versus unit test, because there is the sense of unit tests in the context of like testing methodology, where you're talking about unit tests versus functional tests, integration tests, end-to-end tests. And that's not really what I'm talking about here. When I'm talking about UI tests and unit tests, I'm really talking about these 2 test targets that you can create in Xcode. If you go to create a test target, you get 2 choices. You can create unit tests or UI tests. And the main difference here is that unit tests are in process and UI tests are out of process. So what that means is that when you write a unit test, in this case, this test search function, you run actually in the context of your app, and you have access to all of the code that your app has access to. So if in your code, when you perform a search, you use something, you have a search module that you use, you can actually instantiate a search module here, call perform search for the string love, get a result back as probably an array of strings or something like that. And then you can call this function xctassert, which will fail the test if whatever's inside returns false. So we check that it contains this character, which is ai, it's the word for love in Japanese. Now, to test roughly the same functionality in a UI test, this runs out of process, which basically means that it actually is a separate app. And so this code does not run inside your app, and if you tried to instantiate a search module, the compiler would just complain saying, hey, I don't know what search module is. So instead, UI tests actually simulate interacting with your app just like a user would, with tapping the screen. So in this case, we would actually look for a search field on the screen, let search field equals app.searchfields.firstMatch. It would find the search bar. We type in there the string love. And then instead of looking through an array of strings, that's our search result, we're actually testing to see if the actual cell, in this case I'm using a table view, so if the table view cell with the text I, the Japanese word for love, exists, and we use that same exact xctassert method to check for that. So our first goal here now is to actually get this coverage of having testing that covers this one little square that I pointed out here, so search screen in one particular configuration. And to do that, we'd take our search test that I defined earlier, and we'd expand that into UI tests that cover all of the different pieces of functionality on the screen. So say it has a recent searches functionality, where you can like tap on some recent search you made to search that again. We'd have a test for that. Say you have clearing, so when you want to make sure that when you hit the clear button, all of the search results disappear from the screen. And you can imagine how we might have, say, 10 or 15 different tests here that exercise all the functionality on this screen. And so that gets us basically this far, where we fill in one of these squares, and we have coverage on this square. And our next goal here is to expand this so we cover the entire search feature. So we want to be able to test and have coverage verifying the correctness of the search screen in all languages, on all devices, in light and dark mode, on all iOS versions, with all dynamic type sizes. And the way we do this is using automation. In my case, I use Jenkins, but this is going to be any sort of continuous integration server like CodeMagic or Xcode Cloud, Circle CI, whatever you happen to use. And we can use that to create different configurations of all these different types that I described here earlier. And in Jenkins, for me, this is what that looks like. This is a configuration matrix, and it defines all the different parameters that I test in all these different, basically these multiplicative features, these different configurations that I'm testing in. So this leftmost column is the different devices I test on. So I have an iPhone SE, an iPhone 10, an iPad, and a 12.9-inch iPad. The next column over is the different OS versions. So in my app, I only support 2 OS versions at a time. So I have the oldest, which is right now iOS 16, and the latest, which is iOS 17. The next column is light or dark mode. And then if we switch to the right, these are the different languages that are supported by Nihongo. So English, German, Spanish, simplified and traditional Chinese, French, Russian, and Dutch. And then this one is the dynamic type size. So L represents the standard dynamic type size in iOS, and XXXL is the largest non-accessibility dynamic type size. So every one of these squares represents a unique combination of these different parameters. And ideally, I might run these tests on all these, but practically, UI tests take a while to run because they actually simulate the real user interacting with it, so they run in real time, more or less. So I've chosen a subset of these to use that gives me good coverage, at least one of each value of each of the different parameters here. For the different languages, I choose to run them all on an iPhone SE. This is the original iPhone SE, so this is just to get a 4-inch screen size, so I catch any localization like strings text being clipped or something like that. And the way that you'd configure this is going to depend a lot on your CI tool. You might configure devices in the CI tool, use Xcode test plans to configure things like the language it's going to run in. And there's a lot more I could say about this, but I'm going to leave that out of this presentation. And if you want to find me after, I can talk a lot more about how I configure this. So that gets us this coverage of the search screen. And now you can imagine how if we wrote UI tests that would cover each of these different areas of functionality in our app and run them all these different configurations, we can get our coverage to cover this entire gigantic structure here. So that's UI tests. And next I want to talk about unit tests. UI tests are what I think of as covering kind of the surface of this whole structure. But if we want to do unit tests, the next thing we'll do is we'll kind of take this and crack it open and look at the guts that kind of spill out of it. So here we go. So this is kind of how I think about my app. And I have these surface features that are the ones that interact with the system and interact with the user. And then I have the things kind of on the inside that don't have direct interaction with the system or the user. So for example, something like a text parser. This is something that takes Japanese text, splits it into individual words, which is a hard problem in Japanese because there's no spaces. It connects each of those words to links them to definitions in the dictionary database I use. Another one is deck serialization. So if you have a flashcard deck and you're going to save it to be able to share it with somebody else, I have a deck serialization component that I use. The conjugator, this is something that takes a Japanese verb and will conjugate it into all the different forms to display in like a conjugation table. And does the reverse too, where it can take conjugated verbs and try to find base forms so that you can find that when someone searches for a conjugated form of a verb, it can find the original one and hook it up to a dictionary entry. So in my app, I wrap these up in unit tests, and I basically just do this for any modules that have clear inputs and outputs and don't touch the system. I actually don't try to mock or stub the system at all. I leave that entirely to UI tests, and I'll talk a little bit more about why I do that in a second. So that was unit tests. This is UI tests. And you might have noticed that I focused a lot more on UI tests in this talk. And that's because I'm a huge fan of UI tests. I think this is kind of an unpopular opinion, but I think that UI tests are the most natural tool for verifying app correctness. And for my app, they account for probably about 90% of my tests, probably about 90% UI tests and 10% unit tests. And one of the main reasons for that is that I think UI tests directly answer the question of, does my app work as I expect it to? So what I want my tests to do is give me confidence when I launch my app that my users won't encounter bugs. And at the end of the day, users don't care about whether a bug is Apple's bug or it's your bug. They just care about your app working. So I want to test the whole flow and not just the part that runs through my code. And so when I have something that interacts with the user, I know that some part of that could be in the some part of that is my own code, but some of it is dealing with navigation controllers and delegate callbacks from the system and UI split view and all of these sorts of things that can also muck things up. So in my experience with iOS app development compared to my experience doing distributed systems work and security work, I find that app development, the bugs that I encounter, are generally much sort of closer to the surface. And what I mean by that is it's part of those interactions with users. It's the outside of this that I find is I find way more bugs in say something like interactions with UI split view controller and how they transition between different display modes, or the timing of a delegate callback or something like that. So a lot of the code is a lot more closer to the surface. A lot of the code deals with user interaction in a way that some other software projects don't. And yeah, so like I said, common app dev bugs, interaction with UI frameworks like UIKit and SwiftUI, interactions with users. It's about those the actual events of people touching and doing weird things. And disruptive OS updates. I mean, compared to some of the other work I've done, iOS just breaks shit all the time. Like I've been developing this app for 10 years, and I can't tell you the number of times that they've broken something in like my navigation controllers or navigation bars or appearances or something like that. So this is kind of my approach to testing in Nihongo, and I fully appreciate that all apps are different. and your mileage may vary, and everything has trade-offs, but in my experience, UI tests have been really, really powerful and really useful. And I could give a whole other talk on how to use them effectively, but I don't have time. Oh yeah, so I did mention earlier that I don't stub or mock anything for my unit tests. And again, I think that's kind of an unpopular opinion, but I've seen code bases that just completely contort themselves and bend over backwards to make every component testable and add these layers of abstraction. And sometimes these layers of abstraction can make code really hard to read. And I think that's a real trade-off. Like, I think when you can call a system function directly in the place that it kind of makes sense naturally in the code and not wrap it through some abstraction layer that you've used so that you can stub that out for unit tests or something like that, again, different projects have different requirements. I'm an indie dev. I'm not working on a team with a bunch of other dependencies, but there is some real trade-offs there. And I've just seen things where when you have, oh, wow, am I out of time already? OK, well, lightning round. I'll try to do this really quick. Next step with UI tests. There are a few more things that we can do. One of the things I wanted to highlight is accessibility audits. This was the question that came up in the quiz. Sorry about that. Xcode 15 adds accessibility audits. Another really powerful thing you can do in UI tests, you can basically run this one function and get tons of really useful information about accessibility. Screenshot tests are another really powerful thing you can do with UI tests. This bug that I showed you earlier, the layout issue, was caught by a screenshot test where basically the old version of the app had ran a test that would do this configuration with toggling the sidebar and then changing the into compact width. And the new after iOS 17 update, this layout issue was introduced, and I was able to catch it immediately with this screenshot test that would just run the test, take the screenshot, and then alert me when that changes. And last, localization. UI tests are super powerful for localization. Here's this one screen in English and another screen in German, and you can see there's this string that's being cut off here. Yeah, really powerful to have exhaustive UI tests that touch every part of your app, and when you get translations, you can really quickly identify issues like that. So how do I manage complexity and feel confident in each app release? This is my wrap-up slide. I add multiplicative features carefully. I use unit tests for internal components. I have UI tests that cover every screen in my app, which I run across a variety of configurations via CI, continuous integration. And I use accessibility audits and screenshot testing. And thank you very much.